Okay, Anupam, this right here is for you. This is from the 2020 MIT Integration B qualifier. It looks kind of intimidating, but it's actually not so bad if we simplify each and every part carefully. That's all, right? Anyway, as always, if you guys want to try it, go ahead and pause the video and try it first. This is how we can do it. Starting from this, right? So let me just recall. Let me just say, here we are going to use this. We know that if we have the sum, let's say k goes from 0 to n of x to the k's power, this right here is nicely equal to x to the n plus 1 power and then minus 1 over x minus 1. And you might see some people write it as 1 minus x to whatever and over 1 minus x. That's okay because you can just rearrange the order. The negative will cancel out. Doesn't really matter, right? This is easier because we have x minus 1 right here in that order. Okay, notice that takes care of the bottom, and for the top, doesn't it look like a derivative? Yes, it does. So go ahead, just differentiate this right here with respect to x. And can we do that? Yes, because this is just a finite version of it, so we can totally do that. So we can just go ahead and have the following. This is going to be going from k is equal to 0 to n, and you bring the k to the front and you minus 1, so you end up with kx to the k minus 1. And notice though, if k still goes from 0, you put it here, that's 0, so it doesn't matter. In fact, k, you can just write it as goes from 1 to n, like that. Alright, and then for this, of course, we have to use the quotient rule. So let's go ahead, square the denominator, and then take the bottom one, put it on the top, which is x minus 1 times the derivative of the top. Derivative of the top, you bring this power to the front and then minus 1. So we get n plus 1 times x to the n's power like this. And then we minus the top function, which is x to the n plus 1, times the derivative of the bottom, which is just 1. So that's it. We can simplify this a little bit, so let's go ahead and do that. Here, the bottom is x minus 1 square. And for the top, I will multiply this out first. So you see this is going to be nx to the n's power plus x to the n's power. And then I will do this times that, which is n, and then x to the 1 and n, so it's n plus 1. And then I'll do this times that, which is plus x to the n plus 1. And then I will have the minus 1 times this and that, so it's minus nxn, and then minus x to the n. And then in the end, we'll have the minus x to the n plus 1 right here, right? So that's pretty much what we have on the top. And can we simplify anything? Yes. This and that cancel out, very nice. And this and that we can combine. Sure, that's about all. So we will have the nxn plus 1, and perhaps you can write this minus, and then n plus 1, and then x to the n's power, all over x minus 1 squared. Right, so that's pretty much it. And now you might be wondering, this is not the same as the top though, because the top right here start with 0, this start with 1. But it doesn't matter because we can just do the following. As you can see, inside here, let me just do k plus 1 for all the k's inside. So I have k plus 1 times x to the k plus 1 minus 1, which is x to the k. So I add 1, add up 1, right? And you have to balance it. For the summation, subtract 1, subtract 1. So it goes from 0 to n minus 1. So this is going to be for the top. Very nice. Now, let's go ahead and get to work for this. Here, the first one is integral 1 over x minus 1. Good. Next. And as you can see for the top, well, 2018 is equal to n minus 1. So that means n has to be 2019. And I just have to put that into this formula. That's pretty much it. So we'll see. Here, n is 2019. X to the 2020, right? Because you just add 1 to it. So it's x to the 2020. And then 2020 and then 2019. So it's minus 2020 x 2019. Over the bottom is x minus 1 squared. So this is what we have. And then for the bottom, it's just the original version. So as you can see, n is 2019, and I just have to add 1 right here, right? So we have x to the 2020, and then minus 1 over x minus 1, like this. So that's pretty much it, yeah. Now, have a look. Here is the integral, and we are not integrating yet, but almost. This and that can cancel, and one of them left. And this goes down to the denominator here, right? So, the second fraction is going to be this. 2019 x to the 2020 minus 2020 x to the 2019, and then this and that. So I'll put down x minus 1, and this is x 2020 minus 1, like this. What can we do next? Well, combine the fractions. So right here, I just have to get this over there. So x to the 2020 minus 1, yeah? So I need to have x 2020 minus 1. Have a look. This is x to the 2020, so is that, isn't it? So we can combine it. As you can see, here is the integral, and this and that is 2020 x to the 2020. Yeah, and then minus 2020 x to the 2019 all over this for the denominator, x minus 1, x to the 2020 minus 1, like this, yeah? And then what can we do next? Of course, factor things out. On the top, we can factor out 2020, yes, and then x to the 2019. Am I right? Yes. And then this right here will be x left, and then minus 1. So you see this and that cancel out nicely. Very good, huh? And then here is the integral. On the top is 2020 x to the 2019 all over x to the 2020 minus 1. And do we see what the answer already? Yes, because the top is precisely the derivative of the bottom. So all in all, this is natural log absolute value of the bottom, which is x to the 2020 minus 1, like this. Right? So that's it. So just put on the plus C. On the answer key though, they have this in the different order, 1 minus x to 2020, and they didn't use the absolute value. But if you have the absolute value, it's the same. Alright, so that's it. Hopefully you guys all like this video, and if you do, let me know. Anyway, that's it.